Okay, so the area of a trapezoid is 1/2 times the height times base 1 plus base 2. So here's how I remember area of a trapezoid, because it's kind of a weird one. I think of it as, since a trapezoid has 2 different size bases, how do we find the average of 2 numbers? So you add them together and divide.
Well, why not just add the area, or find the area of the rectangle and then find the area of the triangle?
That's what we were doing before.
Then why not keep going?
You can, but sometimes you may not have all that information. So this is a different way of getting to the same place. So the average of the bases, because if you have 2 different sizes, average of the bases is when you add them together and divide by 2. Once you have the average of the bases, you multiply it by the height. So think about a normal quadrilateral, like a parallelogram or a rectangle, is going to be base times height. We're following that same pattern here, but since we have 2 different bases, it's like finding the average of the bases, multiplying it by the height. All right, so we got the lovely state of Nevada, and guys, I'm planning on driving through Nevada on spring break, and it is not lovely. It is just nothing. There's nothing. Not even Winnemucca.
Drive through Vegas.
That's like down here. I need to go here. So we go through Reno, and it's nothing. 0. There's just nothing. But
Not trees.
nope, not even trees. There's just nothing. But fortunately, Nevada is pretty trapezoidish in shape. So we're going to find the area of this trapezoid. Base 1 is going to be 205. Base 2 is going to be 511. Our height is going to be 309. So we're going to go, I want to add base 1 plus base 2, but I am not a horizontal adder. I'm a vertical adder, so I'm going to go 205 plus 511. So 516. So we got 516 divided by 2 times 309.
Oh wait, no, it's 7.
Is it 7? It's 2. Oh, it's not 3, it's 5. Thank you, guys. Thank you. 716. That was almost a tragedy to the state of Nevada.
358, right?
So I'm going to do a little mental math because I'm not super smart. So 2 goes into 7
Twice.
3 times with 1 left over.
And then there's...
Oh, we'll just do it. We'll write it legit. 2 goes into 11 5 times with 1 left over.
358.
Yeah, 358. Then we got 358 times 3. $15. 1,074, and I better doggone check that because square miles, because I'm feeling like we should check that.
Multiply by 309.
No, isn't it times 309? Not 3?
Oh, interrupt. I was like, boy, that feels really small. Yeah, so let's try this again. So we're going to go here. 309. I got, because I was,
What?
okay. So here we are. We're changing this 3. So, Dylan, are we going to start out with a 2 out of 4? Or
I'm using my calculator.
Okay. Is it okay or not okay to use calculators on your phone?
I mean, why not?
Not okay. There's a whole box of them in the back. You definitely can borrow a calculator. It's super fun. Okay.
I'm gonna steal that one.
Sorry. Sorry, that's a surprise. Okay. So we've got 716 divided by 2 times 309. That is 110,622 square miles. I'm going to say it, but you guys aren't going to remember this. But so I'll write it down. Make sure you include units in your answer. Or you lose points. What other super easy thing do you lose points on a test if you don't do? Show work.
Yeah.
Let's do trapezoids again. So we're also going to come across situations where they're going to give us the area, and we're going to have to work backwards and find one of the bases or the height. So if we start out with our basic trapezoid formula, area is equal to 1/2 height times base 1 plus base 2. And we have a height of 4, base 1 of 4, and an area of 20. We're going to plug these into this little formula. H is 4, base 1 is 4, we don't know base 2, and we're going to divide that by 2. All right, so we have two decisions here. We can either, and we'll take a vote on what we want to do, we can either go 4 divided by 2, or we can multiply both sides by 2 and then divide both sides by 4. If you would like to simplify 4 over 2 first, raise your hand. If you would like to multiply by 2, then divide by 4 to solve this equation, raise your hand.
How did you multiply by 2?
What is the opposite of divide by 2? That's a super awesome question.
I don't know. I didn't do that.
Okay.
Alright.
What's the opposite of dividing by 2?
Multiply.
Right, so that's why. So we're trying to solve for B, for the second base, B2. So to do that, I got to get rid of this 4, I got to get rid of this 2, and I got to get rid of this 4. You're eliminating everything with the base 2. Yes, ma'am?
Couldn't you just multiply 20 by 2 and work backwards from there?
That's what I'm asking if you want to do.
Wait,
It's one of the options.
take away the 2 with the 4 and divide 20 by 2, and that equals 10, and then 10 equals 4 plus B, and you
Yeah,
minus 4.
So here's, I'll do it both.
6.
I'll do it both ways. So here's what I would do. I would go 4 divided by 2, because I can do that really easy in my head. Then I would divide both sides by 2. And then I would subtract 4. And that is centimeters. Or you can say, if you don't like that pathway, you can say the opposite of dividing by 2 is multiplying by 2. The opposite of timesing by 4 is dividing by 4. And the opposite of adding 4 is subtracting 4. And the answer is 6 centimeters. Either way, super fun. Doesn't matter. Yeah, Jeff?
Actually, it's good. On the first one,
4 divided by 2
but the 2 doesn't go away.
is 2. So I just did 4 divided by 2. Or 4 over 2.
The 2 doesn't go away.
No. Not unless I divide by 2, because that's the opposite. it became that too. Just grading your algebra review exams, some of you guys would factor out like the 3, and then in your answer forgot to put the 3 in the front after that you factored out. So I can see that being a question that you guys might have. All right, now we have the humble rhombus and the humble kite. The area formula is the same for both of them. One thing I'd like you to do on this paper is to put an alert. Alert. This is a Pythagorean theorem warning. Check out this shape of a kite. This kite is made up of 4 different whats? Not just triangles, right triangles. Anytime you have right triangles, you should be Pythagorean theorem warned, because it's super sneaky to work Pythagorean theorem into right triangles, even though the learning objective to this is finding the area of a kite. They're always super sneaky on you. So just have, if you see a right triangle, your Pythagorean theorem warning alarm should go off. Okay, so we're finding the area of the kite. We have got, we want, the formula for the area of the kite is 1/2 diagonal 1 times diagonal 2. So we'll call this D1, and we'll call this D2. I don't know D1 because I don't have any information about that line right there. But I know that D2 is twice the 5. 2 times 5 is 10. So guess what I'm going to have to do in order to find this distance here? It's not even diagonal 1, because I'm going to have to add 5 to it in order to get the whole diagonal. So we're going to have to do Pythagorean theorem. So I'm going to pull this little triangle out so you can see without interruption. We'll call this B. What that height is of our triangle B. So we've got A squared plus B squared equals C squared. This is actually one of our Pythagorean triples. So remember on your midterm, which is on Friday for you guys, we have made, on our Chapter 7 test, you guys remember what I let you use on your Chapter 7 test? That's Chapter 8. I actually let you use the Chapter 7 review worksheet, so that you can use on your midterm. This is also true for the final. On Chapter 8, I let you use the triangle mind map and the little triangle thing we made.
And Chapter 9 was a little piece of paper.
Right. So we can use a Chapter 8 mind map. On Chapter 9, we had the little cheat sheet that we made, so you can use that on your midterm. And then we haven't taken the Chapter 10 test yet, so that's whatever we do for Chapter 10, you can use on your final 2. So if you're not saving those things, you have 2 days, today and tomorrow, to recreate them so that you can use them on your midterm. All right, so Pythagorean triple. We got 25 plus B squared equals 169. 169 minus 25, I actually know this legit for real, is 144. So B has to equal 12. So this distance here is 12. This distance here is 5. So D1 is 12 plus 5, which is 17. So the area is 85. 170 divided by 2. And I'm looking for the units. When it doesn't have units, we just put U squared. U for U.
12 is only.
Yeah. From here to here is 12. Chris is absolutely right. From here to here is 12.
That's why you have 17, but I got it.
And then this little guy is 5. 12 and 5 is 17 altogether.
Okay. And you add it?
Okay.
All right, so I'm going to give you guys one more method.
Okay, I know, I got it.
But I need a little room because my handwriting is giant.
Oh, okay.
Okay, so I have this shape right here. We've all agreed was a right triangle. And how do we find the area of a triangle? Yeah, so the area of a triangle is 1/2 base times height. How many of these triangles that I outlined in red do we have?
2.
2. So I'm going to go 2 times 1/2. The base is 5. The height we use Pythagorean theorem is 12. And then I have this triangle here. There are 2 of those, this one and this one. The area is 1/2, base is 5, height is 5. So if you completely forget the formula for the area of a kite, and the only way you would do that is if you don't write it down in our little study tool that we make, then you can go back to, I know what a triangle is, I have the base and the height of a triangle, I can go back and find those. So what's half of 2? Half of 2?
1.
1. So when I have half and a 2, I can just go, that's 1. So this is essentially 60 plus 25, which is 85. So you guys are at the point now where we have a couple different methods to find the same thing. All right, vertices of a rhombus, as I call them out, you guys will graph them on your graph, is -2, 0 for A. B is 0, 4. C is 2, 2. And D is 4, 6. Okay, that looks like this guy right here. Okay, we want to find the area of the rhombus. So we need to find the diagonals. Because the area formula says we got 1/2 diagonal 1 times diagonal 2. Diagonal 1 is the distance between B and C. So let's go ahead and write down the distance formula that we thought maybe we might possibly forget, but keeps coming back like a virus. So the distance formula is the x's subtracted and squared plus the y's subtracted and squared, square root. So for D1, we're going to let x1 be 0 and y1 be 4, x2 be 2, and y2 be 2. Y2 be 2. That's kind of my new song. Y2 be 2 be 2. Okay, so x2 is 2, x1 is 0, and we square it. Y2 is 2, y1 is 4, we subtract them and square them. 2 minus 0 is 2, 2 squared is 4. 2 minus 4 is negative 2, and negative 2 squared, when I have the negative inside the parentheses, it makes it positive. Also 4. This is square root of 8. I'm going to leave it there. I can simplify this down into 2 root 2, but I'm not going to start simplifying things down and making them crazy radicals until the very end, because I know I'm going to multiply distance 1 times distance 2. So I'm hoping whatever ends up underneath the square root is going to be a perfect square. Fingers crossed. All right, so let's find distance 2. So let's go ahead and circle distance 1 so we don't lose it. Distance 2 goes from A to D. The lines are super straight. So we're going to go x1 is negative 2, y1 is 0, and x2 is 4, and y2 is 6. So then we get 4 minus negative 2 squared, and 6 minus 0 squared. Minus a negative, thank you, Algebra Foundations, for doing that lesson this week. Minus a negative is the same as plus. So this is 4 plus 2, 6. And 6 minus 0 is also 6. And this is 36 plus 36, which is also known as 72. So D2 is 72. Let's go back to our formula. 1/2. D1 is root 8. D2 is root 72. We have done enough radical expressions to know when I have 2 radicals multiplied next to each other, we can put them underneath 1 radical. Eight times 72 is 576. Square root of 576, crazy enough, it is a perfect square. Is 24, and 1/2 of 24 is 12. Drop the mic. Yay. We did it, guys. We did it.